Why are we here? This is a graph of transport emissions from the UK, greenhouse gases. And what you can see is that transport emissions there in the middle have hardly budged in the last 30 years. Now, that's not all maritime, but you can see that energy has had huge successes and other things haven't shifted. So this perhaps gives us some indication of the importance of the gathering that we have here today. But let me give you some more. I do a lot of work on life cycle assessment and carbon footprinting. And I always find it fascinating when I look at things, and one of the questions we're always asked in the biomass world, why on earth do Drax bring all those millions of tons of wood all the way from the US to the UK and use them? Answer, it uses hardly any carbon. It's a really good idea because there is very, very little carbon expended in shipping stuff around the globe. So you have this conundrum that maritime, which is one of those sticklers in that carbon graph, is actually one of the most efficient ways of moving goods around the planet. So I absolutely concur with what was said earlier, get stuff off roads and into coastal shipping and out of aeroplanes and into shipping. So, decarbonising maritime, what are the challenges? And I'm putting challenges here not from a technical perspective, but from an emissions perspective, because that's what I spend a lot of my life doing. First of all, you deal with territorial emission limits under the IPCC, the UNFCCC, and yet maritime, by definition, is almost always inter-country and international. So you have jurisdictional issues, you have reporting issues, and you have trying to extract the data you really want. This is why life cycle assessment, where we look at products and the carbon emissions they have incurred in getting to you, actually becomes so complicated. That gives us rather problematic governance, line of sight, and real challenges around incentivisation. Because what if the UK, as was suggested earlier, does lots of wonderful things with green maritime corridors and puts lots of money into things, and yet it doesn't make a difference because it's swamped by what China and the US and others are doing. So we have problems with governance at the correct level for maritime. We also have this complexity around life cycle carbon footprinting. I said that, you know, the ability to move stuff around, I think it's 0.1 megajoules per ton kilometre, is the energy in moving a ton of stuff by ship. And if I take that by aviation, I'm looking at more like 10 to 15. So it's 2 orders of magnitude higher. So we have this life cycle thing which gets hidden because people are only looking at what is done on a territorial basis. The attribution is complex, it's a can of worms when you open it up, and there are cross-sector impacts, and I will come back to this one a little bit because I've got an example for you. But first, let's talk the obvious thing. This session is entitled Low Carbon Fuels. I worked as a combustion engineer in industry before I was in academia, so fuels are the thing that I possibly know most about, possibly. I do a lot of work on sustainability these days, and maritime fuels have historically been the cheap byproduct of the petroleum industry. We produce the stuff we really want for the high-spec things like aviation and cars, and the maritime gets what's left. So they haven't been particularly carbon efficient in their production, and it's important to understand that a refinery doesn't produce just one thing, that we are producing multiple products at the same time, and this is where we come back to that issue of complexity on attribution. That if you decide that you're going to swap maritime out with more ammonia, hydrogen, whatever fuel you want to use, frankly, what happens to the whole system? Are we still producing the kerosene? Indeed, are we still producing the chemicals, the waxes, the greases, the materials that also come from the petroleum that you all need in your daily lives, that most of you are sitting on at the moment? So all of those things are important too. You cannot just decarbonise maritime with a low carbon fuel and think you have done your job. The system and the systemic impacts are important. Now, to date, what have we done? We've used lots of biofuels. There's been comments on this previously. I have spent decades looking at the real carbon footprint and real sustainability of biofuels. Come to me in the lunch break, ask me about any biofuel you want, and I promise to give you some comments on it. The reality is that based on the Department for Transport's own figure, what we have done to date is giving us good savings. We have a robust framework in place, and you're typically looking at savings of the order of 70% or so on what we are producing today. Now, given where we are with the climate crisis, I think 70% is worth having ASAP, please, as cheaply as possible. But the volume is limited. I am going to agree with that. And prioritisation at the moment is elsewhere. One of the documents that was shown in one of the slides earlier was the biomass strategy, produced in August 2023, and prioritises the use of biomass for negative emissions. Also one of my favourite topics. Happy to talk about that later if anyone's interested. But the reality is that this means that the amount of biofuel that will be available for the maritime sector will be limited moving forward. And transport emissions, of course, are about more than fuels. They're about the vessels, they're about the use, the patterns of the journeys that they have, where these fuels are sourced. And one of the things that bothers me immensely is that we are not thinking whole systems, and we are not thinking about the indirect impacts. I hear so many people telling me that they'll solve this with hydrogen and ammonia. Sorry, you're going to do what? You're going to compress that to what pressure? Transmit it at what temperature from A to B in order to get it at a state where you actually can produce it? How much reinforcement of the grid are we going to have on top of what we need for decarbonising with electric vehicles, with heating and everything else? The last sensible estimate I saw said that we were looking at something like a grid 3 times the size of what we have today, and that's without even taking into account the infrastructure that we're going to need around some of these systems. So this is a serious challenge, a huge challenge. And I frankly don't think we're taking it seriously enough at the moment. It worries me immensely when we say that the market will decide and the ports will all do different things and we'll just have this patchwork. I don't think that's going to work. I think we need a plan. I think we need a plan that integrates things to get us there in the most cost-effective way possible, and that actually looks at this at system level. Let me show you an example. This is work that we did in the aviation sector on another EPSRC and DFT funded grant quite recently. And this was aviation fuel. Our calculations are over on the right-hand side around the carbon emissions associated with different pathways to aviation fuel. You can get the carbon emissions down, but if you go to that paper, what you will see is that you do so at the expense of primary energy consumption. You use roughly 3 times as much energy as you do if you just take the aviation fuel from oil. So we've got to look at these wider systemic impacts. The second thing to realise is that you also shift where the emissions show up. They don't show up anymore in transport because you've negated those and you've said, well, that's carbon neutral, that came from there, that's okay. Instead, they start showing up in industry. They start showing up in land use. They start showing up in the other sectors that you thought were down there really low. So those will start, on that very first graph of mine, to creep up if we decarbonise this in the wrong way. So when we think about scale up, it's really important to think about the planetary boundaries here, and to look at the fact that there are breakpoints. So conventionally, in engineering, we love scale up. It reduces cost, and it takes us to the point where things become more viable and more efficient. I've spent the early part of my career working on large power plants all around the world, and big is better because it is more efficient and more cost effective. However, what will we do when we get to the break points in this scale-up game around fuel production? When we get to the point where we have used up a certain resource, where we start to saturate markets, and I think it is really important that we start thinking about how that scale-up process will work. Because the one thing I guarantee is it is non-linear, and it will have points where we need to pause to think about new technologies and about how the next piece will come into play. Resource limitations will affect the embodied carbon as well as the carbon that is being emitted, and that's why this will show up in different sectors, and the energy constraints will come into play as well. So what we will end up with is something that is non-linear. We will get decreased carbon savings for a while, but I think we can then expect things to pop up in strange places, and we all need to worry and think and be creative about the disruptive technologies that actually could move us forward with vessel propulsion, as well as just looking at low carbon fuels. I get desperately worried that we are catapulting ourselves towards a world where our energy resource and our energy use will be vast, even if it is all supposedly green. So we need systematic solutions, we need a sensible policy framing. I'm going to be leading, or am leading, the Clean Maritime Policy Hub as part of this hub, and I would have loved to have talked about this, but as you know, it is the election tomorrow. We are in PERDA, and I do have several advisory roles in different government departments, so I'm not going to do that. Instead, there's my email, and I'm happy to talk to you at lunch.